Guys. In this video, okay, so I just want to start off with saying that, I think a few months ago when I did the video on, well, I think it was quadratic equations by completing the square. I just saw that video actually, and I noticed that, there was like a kind of like a sound, kind of like a windy sound on it, and so I'm just kind of redoing it, just to kind of, for those of you that, if you couldn't understand what I was saying about completing the square, just so that I could go ahead and, kind of redo the video, because apparently I just noticed that it was, it was kind of a problem, and so, just looking at the videos that I did, so that's why I'm gonna do it again. So, with completing the square, if you have a function of the form, y equals ax squared plus bx plus c, completing the square is not that difficult. I mean, like, basically knowing how to complete the square, if you have, for example, a function or a quadratic that does not have a third term, basically you would have to complete the square. And there's also the technique in college algebra and in algebra where you solve a quadratic by completing the square. Give me a second, guys. I'm just trying to understand. So basically you would, let's see here. Just give me 1 second. I'm just trying to give y'all kind of a visual representation of everything that, like, of how it actually looks. So if we go to Google, and I put completing the square, so you can see that, this is kind of what I wanted to show you guys. This is kind of like a visual representation of how it actually looks. So, and I think there would be another one, if I actually look it up on, an actual college algebra textbook, let's see here. It would be, because I feel like it's better represented, in a college algebra textbook, only because, I would tell you how it actually works, but I feel like the college algebra textbook always kind of explains it a lot better. I'm just trying to see if I can actually find it, because I know there's some textbooks that probably don't go over, or maybe they do, but I'm not really sure. Yeah, so yeah, this one doesn't really go over quadratics. Give me a second, guys. Hold on. I'm gonna try to see if I can find another one that kind of goes over it. Because, so basically what I'm wanting to go over is kind of that picture that I showed you where you have like squares and you have kind of a, so basically if you have, for example, so the one that I'm looking at is you would have something like this, right? And then you would have another kind of another kind of square like this, and I'm gonna just try to kind of make it a little bit just so that it kind of looks like the picture. So, and then you would have something, you would have another rectangle over here, and yeah, so basically we'd have something like that, and then there's this idea that this part over here is actually, so this is x, and then this other part is also x. If you hear rain in the background, yes, it's raining, but I'm just trying to, okay, so, and then this part is kind of more, it's more like that. This is going to be b over 2a, and this is also b over 2a. If I just kind of, if I just copy this one, actually, copy, and then paste, and then let's see if I can flip it. Rotate. Okay, so yeah, so this one, it's basically the same exact thing, except the square would be kind of, it's like this, and then this would kind of be over here. And this would be kind of just like that. So that's what I was talking about. So yeah, so we have this part here, and let me try to see if I can just color this a certain color, just so that we can differentiate between the three shapes. And I honestly, like, I would start with the whole, like, explain, I mean, this kind of is a visual representation of why we actually complete the square and how a square would be related to quadratics. Because, I mean, yeah, so, I mean, it's just how it works. And if we have, so this is, these two parts are going to be green, or I'll make them blue, actually. I'll make them blue. So we have this, and let's see if I have blue. So yeah, so this is going to be blue. And you guys can skip over this part. I'm just really, in reality, I'm just trying to draw these shapes and color them and all that other stuff. Just so that y'all can know exactly what I'm talking about. And so that we can kind of differentiate between the shapes. So, and so we have another shape that's, we're just going to draw like a little square. And, sorry guys, hold on. And if we kind of just, move it a little bit. Okay. So this part here is gonna be, I'm just gonna make it a kind of a yellow color. Or make it an orange color actually. So this is gonna be another part, and usually this entire part here would be the one to complete the square. We're gonna call this one b over 2a squared, okay? And there's one more part that is actually really important. It's like a very skinny kind of rectangle. And it's kind of like a purplish kind of color. We're just gonna make it light purple. So it's like this, and the labels of this one are, so we have kind of a this side here, the long side of the rectangle is going to be c over a, and then this other part is just going to be 1. Okay, so basically when you have the form, if you have a x squared plus bx plus c, you are going to have a times x squared plus b over ax plus another one, and then plus c over a. This is kind of how it works. And so I'm just copying off of what the internet is telling me. So now we're gonna explain, how to actually do it, because basically, I mean, a square kind of, it's kind of what we mathematically, I mean, you don't have to know exactly how it works. In fact, this is something that even I, like, this representation here is something that I still don't understand. But what you have to know for algebra, what you do have to know is how to actually do it. So when you have a function, let's just say, let's say that you have something, and I'm gonna try to write one down just so that you guys can understand what I'm talking about, or just so that we can have a problem, because I know there's some quadratics that you make up that aren't really considered. Okay, so we have x squared minus x minus 6 equals 0. Or actually, let me see if I can draw. Maybe let me see if I can do another one. So let's say we have x squared plus 2x minus 8 equals 0. So what you want to do for this one is you want to go ahead and number one, what you would do first, add 8 to both sides. Okay, this would be plus 8 and then plus 8. You would do that, and then this would cancel out. You would have x squared plus 2x. And what you want to do now is you want to add a constant term, because, or a third term, so that when you complete the square, you can actually solve the problem. It's something that you have to remember to do. I mean, because if you don't do it, I mean, it's impossible to say that, it's impossible to just add 8 on both sides and then factor the left and make it equal to 8, because that's not going to be correct. So what you would do is you would add a third term, because you want a perfect square, okay? You want to have a perfect square that you can actually take the square root and then take the square root on both sides, the positive and negative square root, and solve for x that way. So another thing I would say is add c to both sides, And then what you want to do is you want to get the formula. So you say solve for C by the formula C equals B over 2 squared, okay? And so you would say, if here we have, this is A, and then this is B, and then our C is what we have, so we would say C equals, and we know that A is equal to 1, B equals 2, and C, we don't know what it is, okay? C is unknown. We're going to say that C is B over 2 squared, so we have it's B and then over 2 squared, and so you would say 2 over 2 squared, so then you would say that C is equal to 1 squared, so C is 1. That's your C value, so we say that C, so we now have A equals 1, B equals 2, and C equals 1, okay? And so we now say x squared plus 2x plus 1 equals 8 plus 1. So then, now we have x squared plus 2x plus 1 equals 9, and this actually factors into a perfect squared binomial, or a perfect square trinomial, actually, because it's a perfect square trinomial. So, and a trinomial, if you don't know what a trinomial is a equation with 3 terms. So that's like ax squared plus bx plus c, or like x cubed plus 2x plus 1, 2x plus 3x plus 1, etc. It just means that you have 3 things in your equation. So we would say, so then this is a perfect square trinomial. If you guys want me to, I will factor. So it's A times C. This is A, this is C. So A is 1, C is 1. Our B term is 2, so this is where our B would go. This is 2. And now I want 2 numbers that multiply to get 1 and add to get 1. Well, the only ones that I can think of are 1 and 1. So then I would say, I would do my box, and then I would say this is x squared, because in the box method, if you don't know what I mean by that, in the box method, you actually have, this is ax squared, this is mx, this is nx, this is c. The m and n, I got them from, they're actually, this is 1, and this one is also 1. So, so basically you have m x, this is m, and then you would have n x, and this is n. Okay, so then you would say that this is 1x because it's basically it's x, if you want to say that. It's 1x. So then, and then this one would be x, and then your c value is 1. So then you would say x and x are equal to x squared. And x divided by x, so what times x is x? Well, that's just 1. What, and then x times what is equal to x? That's just 1. So then you would say x plus 1 times x plus 1 equals x squared plus 2x plus 1. And now you can rewrite this as x plus 1 squared equals 9. Okay. And then lastly, what you would do is you would, oh, and by the way, right, so you would add c to both sides. C we solved for, the c term we solved for, and we added it over here, and then we got 9. And then the fourth thing I would have you do is factor the left side. And then once you do that, we got this, right? Is equal to, this is equal to x squared plus 2x plus 1. And the one that it was originally equal to in our equation was 9, because over here we got 8 plus 1, so x squared plus 2x plus 1 equals 9. So then we make x plus 1 squared equals to 9. Okay, and then lastly, what I would say is take square root of both sides. And I know some students forget to do this, but make sure it's positive and negative square root. Okay, so the last thing you would do is just take the square root, and you would say, so on the left side, it wouldn't be plus or minus because it's just, we know that the square root of x plus 1 squared is x plus 1 because of the square root property. The nth root of a to the m is equal to a to the m over n. You'll see this a lot more when it comes to like square root functions. But that's exactly why, and this is a square root, so these two things cancel out. And then the right side would be plus or minus 3, because the square root of 9, yes, it's 3, but it's also negative 3. So we would say x plus 1 equals plus or minus 3. And then lastly, what you would do is you would subtract 1 from both sides. Okay? And that would be the last thing that you would do. And so you would say minus 1, so then you would have x equals negative 1 plus or minus 3, and that would be x equals negative 1 plus 3, or x equals negative 1 minus 3. And so you would have x equals 2, and x equals negative 4. And those two would be your answers to this quadratic equation. So I hope that helped. I did take kind of long in doing this, only because I wanted to explain you guys where the property came from and why we actually do it, and just basically why we do it and stuff like that. So I hope you guys enjoyed this video, and in the next video we are going to be actually doing the complex conjugates, and that's basically like dividing, um, complex numbers. So I hope you guys enjoyed, and I will see you guys in the next video. Bye, guys.